let's go down here. Now, the last question. Okay, it looks very similar, but people get thrown by it. Just because the variable, where is the variable? What are we trying to solve for? Where is it?
It is t. It's in the boundary.
That's exactly right. The variable is the upper bound, right? So what this is really asking is, sorry, what's the lower bound? I can't remember. Is it pi on 2? Yeah, okay. So the same as the one we just had. So they're saying, okay, look, start from pi on 2. This is a definite integral, right? Definite integral of this. So it says start from pi on 2, which is here, okay? Now, the question is, with this x here, how far do I need to go integrating this thing? That's it, right? So that I get such and such an area. Now, what is the area? I don't remember. Oh, it's t, isn't it? Though it doesn't matter because it's just a dummy, right? Minus log root 2 minus 1. Okay. So they're saying, look, this is some number. I don't know. Get your calculator out, work it out what it is. And they say, how far do I need to go to get this area underneath here till my area is that big? Okay, which is not the normal way we do it. We usually want to work out what the area is, and these are, defined for us because it's a definite integral. But it's not that hard, right? We've just done this. So what am I going to write on the left-hand side? Okay, so that's my primitive. So I want to evaluate it at the two boundaries. Right?
T on 2.
Yes. Thanks. Okay, so that's what I'm going to evaluate in a second.
No, it's
what
from the last question.
What happened on the right-hand side? We'll get there in a second, Richard.
Oh, right.
Nothing's happened on the right-hand side. It's just a number. Okay. All right, this keeps going. Okay, let's do it left-hand side. Oh, sorry, not left-hand side and right-hand side. Upper and lower bounds. Yeah. So what have I got? Log of 10. Now it becomes an x. And you subtract. Now, hold on. What happened to this before?
0.
That became log of 1, which is 0, right? So I need log 1. Okay, staying with it. Okay, so now this becomes 0. So log of this. Now, I want to get some kind of comparison, right? I'm trying to solve for x. So I want to get rid of all of these logs and tans eventually, yeah? So the first thing I want to get rid of, I suppose, is the log. I have log this over here, but I've got negative log over here. So what impact does that minus sign have?
Make it the minus 1.
That's right. It's the same thing I did here, right? Except I did the reverse order, right? So I've got a minus 1 here, so I want to put it up into the index, like so, right? So that's log of 1 over root 2 minus 1. Okay, so now I've got logs on both sides, so I can get rid of them. And in an exhausted, stressed out exam state, you're like, where is that? What is that? I have no idea what that is, except you do know what that is, right? What's the angle?
Putting it in 2 different parts.
Right, slightly sneaky, but it was really because they just didn't have enough marks to put into one section, right? So this is the angle we just worked out, right? Which is 3 pi on 8. Yeah? So now I multiply by 2, right? Yes? Are you happy? Can we go home? So raise your hand if you're happy at this point. What was this worth? This was worth 2 marks at the end here. So this section down here, 2 marks. Who's happy? Try not to overwhelm me with your enthusiasm. Is that okay? Is that okay? Hold on, hands up straight. Come on, commit, people. I see 1 hand so far. Is that it? 2, 3, 4, 5.
You should write the units, which is
5.
radians.
I'm at 5 so far. Okay, so hands down. That means there's 15 of you who are not happy. Why not? What's wrong with the answer?
Because we're following the crowd.
There's something always goes wrong with that.
Well, but what's wrong? It's pretty good to me.
It's gonna have a thing.
I can give it a go. I can go pi on 2, 3 pi on 4. I can evaluate it, and I'd put money on the fact that it's going to end up
for
on
that. Oh, it does exist. Right.
3 pi on 4.
Yes.
Looks okay to me. Ah. Why would you do general solution?
But it's starting from pi on 2. Oh, because it can minus stuff away from it. That does not make sense. Because if you go to the next thing of the
General solution's onto something. Why, or where rather, would general solution come into play in part D?
Go back the other way.
At what step? Where have I've missed out something quite significant.
can't go the other
Haven't I?
way because then it'll be negative, would it?
No, you're on pi on 2, just halfway between. So you can go.
If you go to pi on 4,
Let's think about this.
because you're going from
If I gave you this as a question,
Oh, yeah, so
Change it
okay,
back.
and I said solve for x, that's all the question says, what would your answer be? Let's just assume radians.
Pi on 4 plus n pi, where n is an element of the set of integers.
I think that's the right answer. If there's nothing given on this, there's no domain restriction on that, you have to say, well, there's heaps of angles that would satisfy that equation. Right? So, if there's no domain, you have to give a general solution, right?
Pi.
But a general solution is wrong
It
here.
should be pi
Isn't it?
plus
Why is
3
general
pi.
solution wrong?
Because
So just in case you didn't, if you're not following, where is this line here? It's this line, right? In the process of trying to get my answer, I've got tan something equals that. I should from here, by all rights say, there's a whole buttload of angles that will satisfy that equation. But why am I ignoring them? Yeah.
Because the 3 parameters is in triangle.
Okay, so we drew the triangle like, I don't know, whichever part it was earlier, to work out this value. This value, right? That was fine, okay? But in question 6, there are no triangles. There are no triangles.
Can we attempt to draw something on the board?
Everything you need to draw on the board is already on there.
In invisible ink! Oh dear.
Okay, so hold on. Let's just regather, okay? We're saying at this point, right? At this point, there are multiple solutions to x, right? But I'm disregarding all of them, and I'm just going with this one. The question is why? Why would we usually say there are lots of solutions, but I only want this one? There are lots of solutions, but I'm going to disregard all of them. What circumstances usually make that happen? Yeah. Ah.
No, but you could minus
If
this
there's a
away.
restriction on domain, like it's a length, it's a time, it's got to be positive, or whatever. Okay. Now, being positive doesn't help us here, right? Because I can keep going, right? But there's something else that causes a problem, right? It's been staring you in the face for the last 10 minutes. I remember I said this is not a triangle question, right? So the triangle would give you some restrictions, okay? It's not a triangle question. What kind of question is this? Where did it start?
Find
Where did it
the
start?
graph of y equals cosec x in the domain.
Remember how I worded it? I said this is a funny question, right? Because the x is in another spot, right? So what is this line saying? It's saying integrate this, find the area under that curve.
Yeah.
How far must I go to get this area?
Yeah.
This is an area question.
No, but can I say what? Can I try and draw?
No. No, sorry. Where's the area start? It starts at pi on 2, which is here, right?
So I said you can go backwards.
And it says go, well, okay, I
If
could,
you go backwards, it'll be a negative.
I'm
because
still
of
in
the-
trouble.
The area is the same.
No, the area is the same.
okay, now, stop for a second. I cannot go backwards, unfortunately. The reason why is because if you get your calculator out, that's positive. I know it looks like it's negative because it's a minus. It's actually positive. Can anyone tell me why?
Because root 2 minus 1.
Because root 2 minus 1 is 0.4 or something, which is less than, that's right, okay. So this is positive. So integrating backwards doesn't help. But if I integrate forwards, you can imagine the area under the curve sort of filling in, right? You're like, where do I stop? Well, wherever it is that it stops, we're suggesting 3 pi on 8.
But you can go
3 pi on 4.
pi on 4 more. And
What
it'll take
happens?
Away, it'll take away that area.
What happens?
It'll minus it.
Because this is an asymptote, right? This area under here, it can't keep going. It breaks, right? You can't evaluate past there, okay, the integral breaks down. Because what it really refers to is an area.
Can't you subtract the breaking down of it by keeping going, and it will be a negative breaking down?
Our maths doesn't deal very well with this infinite distance in here. Right? It's a definite integral. It's a definite integral. Not surely. Think about it. Now, for instance, this thing it's a famous series. It looks like it's going to approach something, but it doesn't. It grows forever. So, let's just tie the threads back together. Okay. At this point here, I can't just go to that answer. Okay. I'm excluding a whole bunch of answers, an infinite number of answers. In fact, how can I exclude it? What sort of domain restriction is there?
X cannot equal pi or n pi.
X on 2.
X has to be in a very specific domain, right? We already said we can't go backwards because then you're going to get a negative area. It won't work with this number, okay? But I have to start at pi on 2. That's taking me forwards, and I can't go any further than pi. Okay. So here I say this is my domain restriction. And that's how I can close off on just a single answer. This is the only one in the domain, okay? Because when you try these guys, they're all outside, okay? And then you land on the final answer, and that's it.